Good afternoon, everybody. Let me pop on my iPad. So we are still on lesson 20. So if you were with me last week on Thursday, we're just continuing on with it, but I told you guys I was going to show you a little shortcut so we don't have to do all of this stuff that we did last time. So that was just 2 problems from last time, all that work, which, like I said last time, it's not really like crazy work. It's just tedious work because you're rewriting the same thing over and over and over. So today, and what I highly recommend that you guys do on your homework, is follow this new rule that I'm going to show you, the shortcut rule, which is actually right on the second page. So I put down, there is a much easier way to finding the derivative. Did you notice what happened in the examples on the previous page? So I don't know if you guys could really see how we went from here to here, especially since we had 3 days off from it. But this was the original function, this f of x. And this part right here is what we call f prime of x. There is a math pattern that happened here that went from the blue to the orange, but again, I don't expect you guys to see that after only seeing 2 examples of this, and that's it. So I'm going to show you guys. If you look underneath, it says that f of x is equal to x to the a, and f prime of x is equal to a times x to the a minus 1. So this is what's actually occurring, and I'm going to show you guys what's happening here. So down here, I'm going to rewrite this f of x off to the side a little bit. So when we go to find, or f prime of x, I should say, when we are trying to go from step 1 to step 2, from the beginning to the end, what we're doing is we're taking the a value. So we have x to the a. We're taking that a value and we're dragging it to the front. So there's 2 rules that goes from step 1 to step 2. The first rule is to bring the exponent out to the front and multiply. So it's kind of similar when we used to do logs. If you guys recall, when we did logs, we would write the word log, and then we would just take whatever the exponent was and we brought it out to the front. Very similar. The part that's different is when we do the second part. So now after you bring the a over, and that's what we did right here, we're just taking this a and we're bringing it to the front. The exponent doesn't disappear like it does with logs. What we have to do is subtract 1 from the exponent. So those are the 2 steps that we're doing. And this is called the shortcut method. This is what mathematicians discovered long time ago, so they didn't have to write out everything like we did on the first page. So I'm going to show you guys from Thursday. I'm going to use this problem right here to show you guys we're going to get the same exact answer of 6x by using those 2 steps. And then I'll do some more practice problems underneath exercise number 2. So we have 3x squared plus 5. So what it tells us to do is look for the part that has the x in it. So right now what we're going to do is we're just going to focus on this part right here, this 3x squared. And the first rule for that 3x squared says bring the exponent out to the front and multiply. So what I'm going to do is I'm just going to take that 2 and bring it out to the front. I'm going to multiply it by that front number. And if I bring 2 out to the front and multiply, it's just saying 2 times 3. So that's going to be 6x. And then what it tells us to do is subtract 1 from the exponent. Well, if we were to do 2 minus 1, we're going to be left with 1. And then I'm just going to write the plus 5 because that plus 5 didn't have an x. It technically does. If there's no x's there, we would say the exponent is 0. So we already did this first piece. We simplified it, and technically we could simplify it even more, and it's going to be 6x because 2 minus 1 is 1. This other part, if we follow the same 2 rules and we bring the exponent out front, we're going to have 0 times 5. Well, if you do 0 times 5, that's just going to be 0. And then it says that we have to subtract 1 from the exponent. So we would have x to the 0 minus 1, which is negative 1. But based on math rules that we've been doing since you guys were in like 1st and 2nd grade, when you multiply by 0, the answer is going to be 0. So that whole part's just going to cancel out. And notice what we're left with. We're left with that same answer of 6x. So this shortcut that mathematicians discovered allowed them to skip over all this work that we just did on the front page. We don't have to do all these substitutions that we did to get down to that 6x. They're like, what's the point of doing that when I could just follow this little 2-step scenario to find my final answer? And this will work every single time. So I'm going to show you guys on part B the same thing, and then I'm going to go through some other problems. So on part B, from Thursday, we started with 2x squared minus 16x plus 35. And that was the f of x. And our goal was to get to f prime of x, which is 4x minus 16. So what I'm going to do is I'm going to follow the same process. So for each one of these, all I'm going to do is take the exponent and I'm going to multiply it by the number out front. So I'm going to start with the 2x squared. I'm going to take the 2 and I'm going to bring it out front because that's the first rule that I wrote down, and we're going to multiply it. So if you do 2 times 2, that's just 4. And then the second step says subtract 1 from the exponent. So if you take 1 away from that 2, I'm really just going to have an x left over. So now I'm going to go to the second part. I'm going to go to that 16x. Technically, the exponent is 1. So what I'm going to do is I'm going to take that 1, I'm going to bring it out to the front of that coefficient, and I'm just going to multiply. So negative 16 times 1 would give us negative 16. And then the rule states that I have to subtract 1 from the exponent. Well, if I do 1 minus 1, that's just going to be 0, so there's no more x that's left over. The last one, there is no x there. So again, like I did before, that technically means I'm going to have x to the 0 power because 1 doesn't exist. And anytime we have x to the 0 power, you'll start to notice that when you go to distribute the 0 is just going to be 0. And as soon as you guys see that you're getting an answer of 0, we don't even care about it. Notice that that answer is the answer that we got when we did all that work from Thursday's lesson. So this is why I told you guys, if you watch the video from Thursday, I told you guys do not do the homework. Because if you did the homework using the method that we did last time, you guys probably would have never wanted to do math for the remainder of the year. Which, honestly, some of you guys in this class already aren't doing that, but that's a different story. Anyways, all I'm going to do is I have 6 examples on here. I'm going to do just a couple of them. There's some with negative exponents. There's some with positive exponents. There's some with fractions. So I kind of want to do one of each, and I'm just going to leave it at that because it's just going to be these same 2 rules on repeat. So letter A, this is like the simplest of all problems if you're looking for a derivative. So if I ask you guys to find the derivative, you're going to follow those same rules as I just said. The first rule being that you want to take your exponent and you want to distribute it to the number out front. So because there's no number there, technically it's saying it's x to the first power because you guys have one x value there. And I'm going to distribute the 1 out to the front. Well, if I distribute the 1 out, that's just going to be 12. Now the second part of the rule states that you have to take the exponent and subtract 1 away from it. So in this case, you're going to have 1 minus 1, which is x to the 0, which means there is no x's left over because x to the 0 would just disappear. So when you guys go to write down your final answer, you just have to make sure this is no longer f of x because what we did in math is the derivative of it. And again, I know a lot of you guys are not going to really truly understand what derivative is. I might have to go into like one word problem with you guys to show you the importance of it. And that will probably be a lesson next week. But this is represented by f prime of x. This is known as your derivative. Okay, so that's a really, really basic one because there was only a single term. It was just that 12x. It was a monomial. I'm going to go to one like part C. Now, if you look at one like part C, this one is a polynomial. It's a 4-term polynomial. So you're just going to use this rule 4 separate times. I'm just doing it on repeat. So I'm going to try to find f prime of x. That is not a 1. It's supposed to be like an apostrophe. So it's f prime of x. And now the rule states that I'm just taking the exponents and I'm multiplying it to the front. Well, the first one is just 3 times 3. So we have 9. And then we're supposed to subtract 1 from the exponents. So I did 3 times 3, which is 9. And then if I subtract 1 away from it, I'm going to have x to the second power, being that 3 minus 1 is 2. Now I'm just going to repeat the process. The next thing I'm going to do is I'm going to distribute the 2 to the 2. So 2 times negative 2 would be negative 4. And then I'm going to subtract 1 from that exponent, which would give us x to the first power. In the next one, it was a hidden exponent of a positive 1. So if I do 1 times that 5, that's just going to be positive 5. But then if you do 1 minus 1, that's just going to be 0. So we're just left with that 5. Well, the last part, it says that I'm going to distribute my exponent. Well, there is no exponent there, so the exponent is 0. So again, as soon as you guys start seeing there's a whole number with no variable, if you don't see an x there, that means this part would just disappear. That means that 12 is not going to even be part of your derivative. So our final answer, you guys should notice we had 4 terms, which is what we started with. When we did the derivative, we now have 3 terms. So that you're always going to lose a term as you go through, as long as you have those, as long as you have I'm like blanking, a constant. That's what I was trying to say. As long as you have a constant that does not have a variable. Notice we didn't lose a term in part A. We had 12x, and then the answer was 12. The reason why we didn't lose a term is because there was an x variable there. Okay? So same rules. I'm just going to keep repeating it. I'm going to come over to part D now. Now, part D is negative exponents. This rule still applies if you have negative exponents. You could still do the same thing. The first step we're going to do is just take the exponent and still multiply it out to the coefficients. Well, negative 2 times 2 would be negative 4. Negative 4 times negative 1 would just be positive 4. So I did the first part. And this, again, is going to be for f prime of x. So I did the first step of the rule. Now the second step of the rule is subtracting the 1 from the exponents. So now we're just figuring out how many x's we have left. Well, if we have x to the negative 2 minus 1, just make sure you're not saying that it's negative 1, because negative 2 minus 1 would be x to the negative 3. Plus 4 to the, well, if we have negative 4 minus 1, that would be x to the negative 5. Once again, we have that plus 3, but because the exponent is 0, there's no x there, we don't even care about it. So we already have the final solution to the problem. So even though they were negative exponents, it's okay. All right. What I suggest, I'm only going to do these last two and then I'll call it quits because obviously there's nothing else that we really need to do. But if you guys look at part E, it says 1 over x plus 3x squared. My suggestion is not to work with fraction terms. So what I am going to do is I'm going to take this part right here and I'm going to make it so it's no longer a fraction. And in order to make it not a fraction, I have to bring it to the top. And when we move variables up and down, you guys may recall that we throw in those negative exponents. 1 over x is the same thing as x to the negative 1. Now that I made the switch so it's a negative exponent, now you guys can solve it with the same rules that we've just been doing in those other problems we've just done above. So I could bring the negative 1 down, and I've gotten to the point where I can do it all off the top of my head, and you guys will too. I don't have to draw the arrows every time. I know that I'm going to bring a negative 1 out front, so I'm going to have negative 1x. I know that I'm subtracting 1 from the exponent, so I'm going to have negative 2, because negative 1 minus 1 is negative 2. I know I'm bringing 2 out front, so 2 times 3 would give me 6. And again, I'm subtracting 1 from the exponent, so I'll have 6x. This is known as f prime of x, and that is known as your derivative. Okay? Last but not least, letter F. Letter F, same type of problem, but this time you'll notice the fraction is the exponent. If the fraction is the exponent, that's okay, because that will work with our rule. So when I go to distribute it out front, we're still doing the same thing. You're just going to be doing it with a fraction this time. So nothing changes. So if I distribute the 2, that's just going to be 2x. And we would have 1 left over because you're subtracting 1 away, 2 minus 1. The next one, you're bringing 2/3 out front. So you'll have negative 2/3 x. And this part you guys may have trouble trying to do off the top of your head. If you do, you have access to a calculator, obviously. So what you guys could do is, because since we know that we're subtracting 1 away from it, just do in your calculator 2/3 minus 1. I already know that the answer is going to be negative 0.3 repeating, which is the same as negative 1/3. But if you guys don't know that off the top of your head, you're okay using the calculator. This isn't an actual pre-calculus class. This isn't an actual calculus class. You're not expected to have to do these off the top of your head. If you have to do it in the future, though, that's where you're going to have to start learning this rule. And again, this is just f prime of x. So you guys will notice that I made the homework very, very similar to what we just did on the back page. Homework 20. There is 10 questions. They're all very similar except when you get to the radicals. So that's why I wanted to jump into the homework real quick to just make sure that you guys know how to change the radicals again, because some of you guys may have forgotten. So I'm going to do 5, and as long as I show you guys number 5, you guys should be okay with number 10. So in number 5, we do not want radicals. My iPad just froze for a second, so I'll let it zoom back in. we have to change the radical into an exponent. There it goes. So I'm just going to look at this part right here real quick. If I want to change that into an exponent, you guys may recall something I did was down and out. We did some review with it on, I can't remember which homework it was, but this exponent is a 1. And technically, because it is a square root, there is a 2 on the outside. If I want to rewrite this as a fraction, so there's no radicals involved, this is really going to be x to the 1/2 power, because what I'm doing is I'm taking the 2 and I'm bringing it to the bottom of the exponent. And now I can rewrite the rest of this, the -1/2 and the x squared. And now you guys can follow those same steps that we just did in the lesson by bringing the exponents out front and then subtracting 1 from the exponents. Okay? So this lesson is kind of a little blah, like I said, because you guys don't know the purpose of derivatives yet. And for math's sake, I did this so you guys can just learn the algebra first. And then we can kind of rewind, and then I could show you guys what the purpose of these are, why it's easier to solve with these, and how it can relate to the real world, because that's what this class is all about. How can we make the math relatable? May not relate to all of you guys, but it may relate to some. Okay, so that is all I have for you guys. We will definitely do a lot more of these within the next couple of days, next couple of weeks. And that's pretty much how we're going to end this school year, is probably just going into this introduction to calculus. Okay? So I hope you guys all have a great evening. Hit me up if you guys have any questions. I know a lot of you guys have been turning in homework assignments. I'm just trying to grade them all. Because when you get about, 200 assignments with about 10 questions each and you have to grade each one, that's a lot of questions to grade. So I've gotten 3 of my classes done. I think you guys, my Math 12 class, are my last class that I have to grade. And once I get through them, I will make sure to send out a reminder to update you guys. Alyssa, my birthday was great. It was kind of a hectic day because not only was it my birthday, it was obviously also Mother's Day and my wife's parents' anniversary. So we had a lot to celebrate yesterday. So it was fun. We grilled some steaks, and then I came home and I played video games. So I had a good day. Yeah, lots of stuff going on. So anyways, I will catch you guys soon. I hope you guys all have a wonderful evening. See you tomorrow. We're going to do some more with this derivative stuff. Yeah, have a good night.